The single most important thing, well, two single most important things. You need to eat enough food, and then you need to eat enough protein. And when they've done meta-analyses and meta-regressions, it looks like even if you're not doing any kind of resistance training, you can see significant improvements in muscle mass and strength if you get your protein up to around 1.5 grams per kilo of body weight. So even just eating enough protein, regardless of anything else, seems to help with body composition.
All right, Dr. Tommy Wood, I am just so pleased to welcome you to The Better Show. Welcome.
Thanks so much for having me. I'm really excited to be here with you today.
We are going to be talking all about the different verticals around cognition and how it changes as we age. And one of the things that I like to talk a lot about on the show, particularly for women, so the demographic that listens to the show is primarily a perimenopausal or a menopausal woman who's trying to sort of, navigate that time period in her life. And I think, the general cohort of a woman in perimenopause and menopause, the messaging around muscles has drastically changed from, and I'm 45, I'm gonna be 46 next month. Like I went from being like a cardio bunny, like always, and I was a step aerobics teacher. Like that's how I paid for my professional schooling. It's like high, low. I'm totally dating myself, but high, low and Taibo and step. But we've really sort of seen a shift towards the positive in recent years around going from being a cardio bunny to almost like we'll call it like a muscle mommy, right? So like women with muscle. So my first question for you with that big preamble is, how can we think about muscle, both lean muscle tissue and muscular strength, in both the prevention of, or maybe the delayed onset of cognitive decline?
There's a number of ways to tackle this, but I think that the first thing to say is that I think it's fantastic that there's been this return or this increase in interest in strength training, resistance training in women of all ages. And I just got a message from a very good friend of mine yesterday who said that after I'd suggested this to her a long time ago, she was finally really enjoying hitting the weight room and really liked kicking it to the patriarchy, because everybody underestimated the girl with the sparkly fingernails who then walked into the
deadlifted her double her body weight. Yeah,
it's just amazing. I love it. It's fantastic. So the fact that this is becoming a message that's out there, I think is brilliant. So when you think about muscle tissue, there are several parts of it that play a role in terms of the health of the brain. When we look at exercise interventions broadly, it seems that any physical activity helps with cognitive function. And the minimum effective dose, regardless of the type you do, is kind of around standard government guidelines. 150 minutes of moderate to vigorous physical activity per week seems to be the minimum dose that increases cognitive function to a meaningful amount that you could detect and would actually make a difference. There are a few meta-analyses of randomized controlled trials that actually suggest that resistance training, particularly for things like executive function, which is decision making, resistance training may be better than aerobic training in terms of improving cognitive function. Now, of course, both are important for different reasons, but resistance training in particular seems to affect some of the white matter pathways. So white matter kind of sits under the gray matter of your wrinkly outer cortex. If you sort of imagine a brain, it's kind of wrinkled on the outside, it's gray matter on the outside. Under that is white matter, and white matter is responsible for fast connections between different areas of the brain and then down to the body. And resistance training in particular seems to benefit those white matter tracts, and interestingly, particularly affects the ones that seem to be affected with age and risk of cognitive decline and dementia. There's also some indirect effects that muscle mass can have. So there are several studies going back decades that show that the more muscle you have and the more you move it, the better your regulation of blood sugar in particular. So your muscles are your main sink for blood sugar. And we know that having persistently elevated blood sugar is really not very good for the brain or any part of the body. So having muscle and it being more active, that those things are both important for blood sugar control. And we also know that when you exercise your muscles, you release a whole host of factors from the muscles as well as from other tissues like the liver. So if they're released from the muscles, we call them myokines. If they're released from other organs, some people call them exokines. And these then support various aspects of brain function. And one that people talk about a lot is called BDNF, brain-derived neurotrophic factor. However, there are dozens and probably several that we don't even know about yet. We're always discovering new exokines and myokines that seem to have beneficial effects. So there's this direct neuromuscular stimulus. And when we stimulate our muscles, we're directly stimulating the brain because we're formulating those connections, learning the paths associated with trying to maximize our strength. And then there's also these indirect effects that are going to be beneficial in terms of blood sugar control and releasing all these other factors that can support brain health.
I also think that depending on the type of exercise, which I would like to get into, I feel like not all exercise is created equal. Like there is a certain cognitive, there's some exercises where I have to be 100% present for what I'm doing. So for example, if I'm doing a low intensity, steady state bike ride, I am also doing my Duolingo. I'm just on my phone. I'm doing other things, right? Versus if I'm doing sprints, there's one program that I use on my stationary bike where it's 8 seconds all out sprinting, 12-second recovery, and you do that 30 times, 45 times, or 60 times, depending on the program you choose. I can't do Duolingo. I can't do anything else other than focus. And the same is true for weight training. So as the weight gets progressively heavier, or even, if it's the appropriate weight for what I'm trying to achieve, sometimes I have to close my eyes and actually get rid of the visual stimulus of the people around me and sort of who's walking by and just get into my muscle in order, I have to bring my mind, if you will, into my muscle in order to perform that movement properly and not to have any compensatory, movement strategy. So I almost feel like it's in some ways it's a cognitive stimulus insofar as I have to focus exactly on what I'm doing. I mean, and so my sort of pre-frame on that is, can you talk a little bit about, am I wrong there? Or maybe you can redirect me. Are all exercises created equal? Because I know that there's some people who will just go for walks, which is great. I love walking. That's wonderful. And if it's the only thing that you do, I think that you're missing the potential upside to some of the things that you're talking about with the white matter connectivity and some of these things that we lose as we age, the release of myokines, or maybe to the same degree if you're just walking versus, pushing yourself in the way that I was just describing.
It's a great question. And part of it is trying to separate out what's good versus is there a better approach. And in general, any physical activity that's more than what you're currently doing is great for your brain. I think we would both agree on that.
Yes.
However, in terms of the process you're describing, I'm not sure we have any really good data to suggest that this is creating its own cognitive stimulus. But there are some, or now several studies that compare exercises that have a given amount of difficulty or cardiovascular difficulty, right? So you're going to get your heart rate up a certain amount as some measure of intensity. And if you compare a unimodal form of exercise, and this is generally in the sort of aerobic exercise sphere, but if you compare a unimodal form of exercise, so you're sat on a stationary bike or you're running on a treadmill, compared to a multimodal, or what they sometimes call open skill movement, which requires reactions, coordination, even though they challenge the cardiovascular system the same amount, the latter seems to be better for cognitive function as well as releasing more BDNF. So there was a recent study that came out where they had individuals running laps on a track, and they did this in a crossover design, and so they were their own controls. And in one, they're just running laps on the track, and in the other one, they put obstacles on the track. So there was cones for them to zig in and out of, things for them to jump under, crawl under, jump over. And even though the intensity was the same, when they added that sort of coordination component, they saw more release of BDNF, VEGF, IGF-1, so some of these myokines. Some people have suggested that part of this is because more muscles are being activated, right? If you're running on a track, you're using fewer of your total muscles in your body than if you're like having to jump and crawl over things, right? So that's maybe part of it. But it does seem that these complex motor or coordination-based tasks that come with physical activity may provide additional benefit to the brain. That being said, when we talk about structures of the brain that are improved with, say, resistance training, these studies are often done in your target population. So maybe peri or postmenopausal women, or maybe slightly later. There are some studies in individuals in their 60s and 70s, and even doing resistance training with weight machines in the gym, which obviously, the path is dictated for you. It's a very low skill movement. Even those show benefit. So I think there does seem to be some additional benefit from coordination or sort of those skill-based sports or movements and or activities where you're having to react to another person. So like a ball sport, so badminton's been looked at. Dancing seems to be one of the best interventions because you've got the physical activity component, you've got a social component, you've got a skill-based component and coordination. So those seem to be sort of like extra beneficial to the brain, but those other sort of unimodal activities also provide their own benefit.
Maybe that's why there's been a resurgence of, you talk about the treadmill or the stationary bike versus biking outside in nature where the pavement is uneven and you have to make sure you're not getting hit by a car. Or, if you're walking, you actually see there's like a depth perception where you're sort of seeing the environment, approach and pass you, again, with an uneven surface, let's say. What I've seen, at least in the sort of machine realm, is that we have those treadmills, but then you're starting to see, I guess they would be curved treadmills where they're trying to replicate maybe a bit of uneven surface and activation of muscles that would be potentially easier activated in the wild, I guess is the way I might categorize that. All right, let's talk a little bit about kind of diving a little bit deeper with muscle. I'd like to talk about the quality of muscle tissue. And the reason why I say that is an individual who, just because you have more muscle doesn't necessarily mean that you're healthier. And I'll quantify that by saying, like, if you're a larger person, let's say, just by default, you're going to have more muscle because you're just a larger individual. Yeah. So talk a little bit about the importance of not just having muscle tissue, but the quality of the tissue. And we'll talk a little bit about how we might think about evaluating the quality of our muscle tissue as well.
There's been a few studies that have come out recently that have started to force us to think about this question in greater detail. So historically, there was a storyline that muscle, regardless of how you gain that muscle, and I would categorize two broad ways of gaining it. Either you are doing specific exercises that are, creating adaptation in that muscle tissue that result in those muscles getting bigger, say with lifting weights, or there's just the process of being in a caloric surplus over time. Right. Your body size increases, and some of that is muscle mass. Those two types of muscle previously were just assumed to be the same, right? Muscle is muscle, regardless of how you got it. And it was thought to be protective. And it is protective up to a point. So there's been this idea of the quote unquote obesity paradox, which is that compared to people who are normal weight or underweight by BMI, which is pretty terrible measure of health. But that was what people looked at. Those who were either overweight or obese tended to live longer. And some of that, based on how the analyses were done, is attributed to muscle mass. So we know that if you have more muscle mass, you have less risk of cardiovascular disease, you're more likely to survive cancers. It's certainly protective broadly. However, more recently, there have been some studies looking at muscle mass and other health outcomes in larger populations. So there was a study that came out from the UK Biobank where they have 500,000 people, and they've done DEXA scans, they've looked at body composition and muscle mass. And this was actually, particularly in men that they saw this, but I think it's still relevant, was that those who had high muscle mass, the highest amounts of muscle mass, actually had higher amounts of heart disease and were more likely to die earlier. However, in the same study, they looked at grip strength, and grip strength, the stronger you were, the better, right? And so there's this disconnect between how much muscle you have and how strong you are that's affecting mortality. Because in general, we think if you have more muscle, you're stronger. But in the general population, most people who have a lot of muscle mass have a lot of muscle mass just because they're bigger bodied people, like you said, not because they're in the gym lifting weights. And so we dug into a paper that I recently published with a bunch of colleagues, where we looked at cognitive function, and we had measures of body composition. So these individuals had DEXA scans. We looked at blood tests, various nutrient things are associated with cognitive function. And then we had leg strength was in the data set. And this is individuals, men and women in their 60s. And what we saw was that muscle mass itself was actually a very bad predictor of cognitive function. It didn't predict it at all. If anything, we saw a similar signal that those who had very high muscle mass had worse cognitive function. I think that's related to overall body composition and health, just associated with being in a larger body. And then when we instead looked at strength was very predictive of cognitive function, as you'd expect. So the stronger people's legs were, the better their cognitive function, after adjusting for physical activity and other health metrics and things like that.
And how was strength measured? Was it 1 rep max? Like what was the measure for strength?
It was an isokinetic leg extension. So this is a machine where you sit in the gym. It's like people are probably familiar with a leg extension machine. Mm-hmm. And what you do is you essentially apply as much force as you can, and it's isokinetic. So however hard you push, the machine pushes back so that you're constantly moving the legs at the same speed. So this was, how much force can you generate with your quadriceps? And a lot of other studies use grip strength in these big population studies, but one of the reasons why I picked this particular cohort it's the NHANES National Health and Nutrition Examination Survey data set in the US was because they had leg strength, and that's it's a bigger set of muscles. It's probably more directly related to physical activity and broader strength. And then the final thing we did was we sort of estimated strength relative to body size to kind of make it fair. Right. And again, we saw that was really, really predictive of cognitive function. So how strong are you relative to the amount of muscle you have relative to your body size? And so that's what I think most people should be aiming for is how can you increase your strength relative to the size that you are? And that means that anybody can improve their health and strength regardless of their starting point and still hopefully see cognitive benefits. And that's what's really important.
I just want to say something really quickly about grip strength. It is very predictive of longevity, but what I have seen, unfortunately, is sort of a misinterpretation of that, where people are starting to just training their hands, and it's a bit misguided insofar as usually when someone has strong grip, it's because they are doing pull-ups or push-ups, or they're generally lifting things in their daily life, which just contributes to forearm, the forearm flexors and extensors and your ability to sort of, dead hang, let's say, for a long period of time. But what I have seen is a bit of a, we'll say, misguided interpretation where people are buying like grip strength devices where they're like little squeezy things, and you're just trying to build out the grip. And that's not exactly right. I wondered if you could comment on that just briefly.
No, I completely agree. When people put together these large population data sets, right? If you're going to measure strength in 500,000 people, it's got to be something quick and easy to do. And the easiest way to do that is with a hand dynamometer, right? You can quickly measure grip strength. You can do it in a couple of minutes. It's much harder to do leg strength, or how much can you deadlift or squat? Like nobody can do that, or nobody's done that at that kind of scale. So you're right. Grip strength is a good predictor, but that's just because it's associated with other measures of strength and muscle mass. So yeah, I've also seen the same thing. Like grip strength is associated with longevity, so I'm just going to train my grip. And there's nothing wrong with training your grip. You should do it. I train my grip because it's important for the sport that I do. But the best training for your grip and everything else is probably just like a deadlift, right? You're going to train your grip as well as a whole bunch of other muscles that are probably going to be more important.
Yes. Okay, good. So we're on the same page with that, because I'm like, what is happening? Why are people, I've seen advertisements for, it's silly. Okay, so in terms of, so your study, you were looking at blood markers, leg strength, this quadricep or knee extension machine. Are there other ways that we can evaluate? So if we're not part of, your study, let's say, are there other ways that we might evaluate the quality of our muscle tissue? So strength would be one of them. Is it like mitochondrial density? I don't know if you can really easily measure that, or, insulin sensitivity, amount of satellites. What are some of the ways that we might, the lay person, let's say, if we're looking at blood markers or any other functional strength tests, what are some ways that we might evaluate the quality of our muscle tissue?
Yeah. In reality, like most even the things that you mentioned are not something that most people can measure, right? You can't, You're not going to get a muscle biopsy and measure your satellite cells. Although probably the best, because we're working on some other studies to try and help people with this actually. And one of the best markers of muscle quality is intermediate type 2 muscle fibers, which you can only measure if you do a muscle biopsy. You also can't measure mitochondrial function. So I think some things are potentially important. So you mentioned overall insulin sensitivity. I think your muscle quality is directly related to your insulin sensitivity and glucose regulation. So HbA1c, fasting blood sugar, fasting insulin or C-peptide, basic lipids like a triglyceride to HDL ratio can be helpful in some populations. So that's some basic things. What we're working on, and we don't yet have it fully published and figured out yet or validated, is essentially a simple predictor of muscle quality based on a few simple blood tests. And we've developed it in a large population, and we're just in the process of validating it, and then we'll publish it. In women, the important markers seem to be things like CRP, so not having high levels of inflammation. Albumin is important. Creatinine is important. In general, people think that creatinine is bad because they use it as a marker of kidney function, but actually creatinine is one of the best markers we have of total muscle mass. And then you can figure out the relative contributions of kidney function versus muscle mass by looking at creatinine versus something else called cystatin C. So there's things like this. We're working on it. It's going to be much simpler. You could just put in your we'll make a calculator eventually, but it's probably a year or two out.
Well, that is super exciting. Gosh, I can't wait for that.
But before then, I think just the final thing is probably, what's your muscle quality relative to your body size is just going to be how do you perform at body weight exercises? How are you good body weight lunges or squats or pull-ups or push-ups? I think if you know where you are right now and you progress in those measures, regardless of where you start, then you know that your muscle quality and strength relative to your body weight or body size is improving. So those are just really simple things that anybody can do.
So we can start with that, and then we'll wait a year for you to publish your next piece, and then I'll make sure that we'll have you back on the show, and we'll talk a little bit about that as well. You mentioned BMI, and I did want to stop here for a moment, because I generally think that for most individuals, at least, one of the big missions of the show is to get women lifting, to help them figure out their hormones and sort of lifestyle modifications, nutrition, etc. And of course, women are culturally and otherwise just exquisitely sensitive to the number on the scale. And I've often said on the show, it's, when we're thinking about weight loss, it's not the, you don't want to lose muscle weight. You don't want to lose organ weight. You don't want to lose bone weight. You want to lose adipose tissue if that's the goal, right? And one of the things that I find with BMI is it doesn't actually matter. BMI doesn't even take into account. So if you put on, let's say, 5 pounds of muscle and you've been training for, 6 months or something, you're arguably a much healthier person than you were, 6 months ago. But your BMI is going to knock you because it's just a total number. They're just looking for weight, right? They're just looking for an increase or decrease in weight. I've heard you talk about the fat-free mass index, and I wondered if you might just expand on that, because for the women who are listening, so my BMI, I did this little experiment just prior to having you on, and I went on to just like an online calculator, and my BMI is 21.8, which puts me in sort of the normal normal category. I did my FFI 18.2, and then
fantastic
normalized. So the normalized FFMI was 19, which puts me in their excellent category. Yeah. Right. So I went from like normal to excellent. So I wondered if you might just you might just talk about the differences between those two and why they're important.
Yeah. There's been a lot of talk about BMI recently, and several health related bodies around the world have started to essentially jettison BMI because it's just a terrible predictor of health, as for the reasons that you state. It doesn't say what your mass is made up, or as the body mass index, it assumes that all mass is equal in terms of our health, when we absolutely know it isn't. And muscle mass and bone mass are just the critical components, particularly if you want to live a long and healthy life. So the FFMI is the fat-free mass index. It's essentially calculated the same as a BMI, but what you do is you just remove body fat to start with, and you just ignore it, because I think in reality we can do that most of the time if we're focusing on muscle tissue. And there are several ways to do it. You can obviously get a DEXA scan, like bioimpedance, where you sort of like measure the resistance of the body. Like some people, you can stand on those scales or hold those electrodes, and it kind of estimates how much body fat you have. And nowadays, for a single point measure, the bioimpedance measures that they're pretty good. Like they're close enough for you to estimate roughly what your FFMI is. Or you can also, there are even images online where it's kind of like, this is what people look like at certain body fat percentages. And you can say, yeah, that kind of looks like me. And then you can just remove that from your weight and then calculate your FFMI. When we've looked at FFMI and say mortality risk in large population data sets, which I've done a couple of times, the lowest risk for women seems to be somewhere starting around an FFMI of 17, and the real benefit, it seems to be sort of like 17 to maybe 19 or 20. Like that's the real sweet spot. Below 14 is where risk of mortality really increases, and that's where you've probably got frank sarcopenia. So you've got muscle loss, bone loss. That's associated with related to a whole host of chronic conditions. So I think putting the BMI completely aside, if you have some way to track your body composition over time, a DEXA or an MRI is gold standard, but that's tricky for people to do a lot. So even just looking in a mirror, there are also now some apps that are pretty good where you can just like take standardized pictures of yourself and it sort of estimates body fat. I think that's where you're focusing on moving the FFMI needle with resistance training or other exercise. Like that's where you're going to see the most bang for your buck.
And so that 14 is sort of like for women, this is like where we're starting to see maybe moving into maybe like pathologically low levels of muscle mass. Yes. Yeah. Okay. And then do you have a similar, just to be complete, there are, we have lots of women that listen to this, but they also certainly have men in their lives that they love. Do we have the data for men? So it's 14 on the low end, but the sweet spot you said for women is between 17 and 19. What is the homologue for men?
So for men, the sort of the minimum is 17. That's where risk starts to increase. And then the sweet spot seems to be somewhere sort of 19 to 21 or 22. Okay. What I will say is that anything above that in the population, sort of in general population data set. So if you have an FFMI above 22 or, maybe 23, 24 as a man or 21, 22 as a woman, that's associated with very large BMIs and large waist circumferences. So these are not people who've generated a bunch of muscle mass in the gym. This is just from a long period of time in a caloric surplus, and some of that is muscle tissue. So what I can't say is that, so I give you kind of that magic range where I think people should try to aim for. If you're above that, I don't think that's necessarily better, but I also don't think it's worse. The problem is we just don't have those data. We don't have long-term follow-up in thousands of people who have high FFMIs in the setting of low body fat percentages, because that's kind of been that body composition has been a focus of their health and habits. There just aren't that many people like that in those data sets. So that becomes a bit of a gray area, is whether being above that is good or bad. So my FFMI is somewhere between 24 and 25. There's nobody like me in those data sets. I don't know if that's a good thing or a bad thing. Honestly, I don't. I think it's not a bad thing, but there just aren't good data around that.
Let's talk about nutrition. How can we use nutrition? We've been talking about muscle and the importance of developing lean muscle mass. We talk about resistance training, cardiovascular training. How can we manipulate nutrition, for better body composition, right? To have, that ideal FFMI that we've been talking about, but also for cognition as well. Are there any general principles that you typically adhere by? Are there, and we can move into supplements certainly, but I want to talk maybe about whole foods first, and then see if we can dive into a little bit more of the supplement realm in a bit.
For muscle mass, the single most important thing, well, two single most important things: you need to eat enough food, and then you need to eat enough protein. And when they've done meta-analyses and meta-regressions, it looks like even if you're not doing any kind of resistance training, you can see significant improvements in muscle mass and strength if you get your protein up to around 1.5 grams per kilo of body weight. So even just eating enough protein, regardless of anything else, seems to help with body composition.
So it's about 0.7 grams-ish per pound?
Yeah.
Am I doing that correction properly?
Yeah, somewhere, around there. Okay. Yeah. So somewhere, I think most people should aim for sort of like 0.6 to 0.7 up to 0.8. That's probably where grams per pound. Most of the research is done in grams per kilo, and then you kind of have to like back calculate.
Yeah, and then you have to, North American it.
yeah, exactly. But there is a real synergy between resistance training or strength training and protein intake. And again, the sort of, if you're going to give an optimal average amount for the average person, it's about the same, somewhere around that 0.7, 0.8 grams per pound. But you see a much bigger benefit if you add resistance training on top, which I think we're not surprised by. In cases where you're in a very significant caloric deficit for whatever reason, then I think increasing that slightly is could provide some additional benefit, but that's sort of like a fairly niche area. You may get some preservation of muscle mass if you're in a significant caloric deficit, but actually the most important thing to protect your muscle mass when you're in a caloric deficit is resistance training. So you keep providing stimulus to those muscles even if you've dramatically reduced your caloric intake for whatever reason. There are a whole number of nutrients that I think will support this process, and they are then maybe what starts to tie nutrition back to the brain as well. So we know that you'll see improved body composition and strength or response to training if you have adequate vitamin D status, if you have adequate omega-3 status. Other things like iron and magnesium become important, and those are the same for the brain. Absolutely. When you think about long-term brain health, there are several randomized controlled trials that have sort of tried to figure out how different nutrients interact. And so two of the most important ones, again, are omega-3s and how they interact with B vitamin status, particularly sort of measured in terms of how high your homocysteine level is. And historically, people have published trials that have said, we thought that omega-3s were going to be like the magic thing for your brain, and they were going to prevent dementia and cure all this, cure all our brain ills. And The omega-3 fatty acids, the long chain ones that you get from seafood, are incredibly important for the brain. But the problem is that in order for them to function and get into the brain where you want them, you need good insulin sensitivity, you need adequate B vitamin status. So if you have low homocysteine and high omega-3s, that's the optimal state. If one or other of those is not good, so you have high homocysteine, then your omega-3s don't get where you want them to go. And if you have low omega-3s but good B vitamin status or low homocysteine, then you don't have enough omega-3s to kind of get into the brain. So they interact, and there are several studies that have shown that. And then again, iron status is really important, very relevant to women and cognitive function, as is vitamin D. So those are probably the main things that I'd focus on. And where can we get those foods? Where can we get those from food? So seafood, obviously a critical source for long chain omega-3 fatty acids. If you don't eat seafood, then you can supplement, but you can also, if you don't want to have any kind of animal products in your diet, then there are like algal forms of DHA that you can supplement with. B vitamins.
Are they the same though? Are they the same?
I think they're going to be close enough. It's not the same if you get alpha linolenic acid, which is the short form precursor that you can get from like nuts and seeds and things. And often foods will be sold as high in omega-3 because they get ALA from nuts and seeds. And how you convert that to the long chain omega-3s, DHA and EPA, which is what you really want for the brain and for vascular health, is very different from person to person. So the algal forms that you can supplement with that have the long chain omega-3s, I think they're fine, but getting the precursor from nuts and seeds isn't going to necessarily be the same thing. Although some people seem to do fine with that, but it depends on genetics and a whole host of other things.
Yeah, it depends on, I guess like polymorphisms or your ability to convert. Yeah. Well, I'm so happy that we're here, because I think that we're at this particular topic, because I think again, I was saying before, women very exquisitely sensitive to weight. And I think one of the traditional sort of strategies forever in terms of weight loss has been caloric restriction. Mm-hmm. I cannot tell you how many women that I've either counseled or cared for that were consuming like 1,100 calories, 1,200 calories, and they had been doing so for, decades. And so when you tell them to eat, 15 times their body, 15 times their body weight, they just about run out the door. Like they just can't, there's such the cognitive dissonance between what I'm telling them and telling them that they are, probably lacking in substrate, protein deficient, mineral deficient, what we've been talking about in terms of growing muscle, I think is so important, not to mention the metabolic adaptations that happen when you're in a caloric deficit for that period of time. Like even fitness competitors, bikini competitors, wellness, whatever figure, like there's an on season and an off season. Like they're lean for a certain amount of time, just to get on stage and do the photo shoots and whatever. And then they eat afterwards. Right.
Yeah.
Let's talk a little, let's double click a little bit on omega-3s. You said something that sort of triggered a memory. There's a couple of individuals online that talk about how omega-3s are rancid and they're bad for you and they're terrible for you. And for the record, I don't agree. I mean, certainly the supplement industry can be a little bit of the wild, wild west. Like I get it. You can buy something from Costco and maybe that's not the same as, maybe a Thorne or Pure Encapsulations or something where there's a lot of R&D and sort of independent testing along the way. But I wanted you to speak a little bit. You mentioned methylation and homocysteine. I would love for you to speak a little bit more about that insofar as when we think about, someone reaching midlife and thinking about, the second half of their life, whether they're male, female, whatever, we know that cardiovascular disease, still the number one killer by far for men and women. It's not cancer. It's CVD, maybe cerebrovascular disease coming after that. Talk a little bit about why it's important for us to keep our homocysteine levels low and the role that, you mentioned B vitamins. I assume you're talking primarily about 6 and 12, but we can sort of round out that discussion. B vitamins and omega-3s and how those work to reduce potentially homocysteine levels in the body.
There are two parts to to the homocysteine story. It's a nice general marker of methylation. And methylation is essentially this process where you move carbons around, and you do it for a whole bunch of stuff, either for certain biochemical processes, to turn genes on and off. It's one of the ways that the body kind of directs metabolism or the function of a cell is through methylation. So in order for methylation to work, you need adequate substrate or methyl groups, depending on how you want to pronounce it. And in general, these come from and are recycled through the use of certain B vitamins, or they require certain B vitamins. B6 is an important one. Several of the trials that have lowered homocysteine, however, have focused on B12 and folate, which is B9. And some of the studies that have shown improved cognitive function and slowing of brain atrophy just used B12 and folate plus or minus B6. The final one that becomes important in some people, but I don't think you need to figure out if that's you or not. You just need to make sure that you consume enough of it that really solves the problem, is riboflavin, which is B2. And that's because some polymorphisms in, so genetic mutations that are normal and lots of people have them, or most people probably have at least one, they affect the methylation system because they affect how the enzyme binds to a proton or energy carrier called FADH2. FADH2 is, or FAD, which it comes from, is made primarily from riboflavin. So you can overcome those issues by just making sure you eat enough riboflavin. And I just mean like the recommended daily allowance, a couple of milligrams a day. So like no massive super doses or anything like that. You just need to make sure you're getting enough. And so those four are the things that I would focus on, but there are other potential nutrients that support this system as well. So choline is really important. That's often that's part of the methylation system. Creatine can be really important because the production of creatine in the body is one of the most methyl intensive processes in the body, and so you can sort of offload some of that burden by getting adequate creatine in your diet.
And just so we can give people actionable items here. So the creatine, typically after a workout, I pop in about 5 grams into my protein shake or whatever. So if somebody's thinking about, but I've been doing that sort of forever. So if someone's thinking of, I don't know if loading is the right word, but if someone's like, oh, actually, I'm not doing that, is just 5 grams daily kind of the way that we think about it? Would you do 20 grams for a week and then just kind of taper it down to like, how do you think about creatine supplementation?
Yeah. So historically, people did a loading dose. So they'd do like 20 grams for a week or two, and then they'd come down to 5 grams sort of chronically. And if you take a loading dose for, say, a week, you can more rapidly increase creatine in body stores. So like in the brain, for instance. However, most people don't really need to do that because you just want long-term creatine intake rather than having to load anything. There was a recent 2-year randomized control study in perimenopausal and postmenopausal women where they supplemented with 10 grams of creatine a day, and with a resistance training. So it was placebo or creatine and then a resistance training intervention. And those who took creatine and did resistance training, they had some improvements in bone strength parameters in certain bones. So I think that 5 grams is great. 10 grams could also be great, but somewhere in that range, just as a daily dose, it is fine.
And this may be a dumb question, but I'm going to ask it anyway. Do we, as we age, one of the things that, I often am looking at literature around anabolic resistance of the muscle. This is why protein, you mentioned more, enough calories and more protein. It's the only macro that really changes, like our requirements really change as we age. Yeah. Do we see the same with creatine? Like, do we also have a resistance to creatine potentially in the same way that we might see some of this anabolic resistance that happens in muscle tissue as we move into menopause or andropause?
I don't think so. The main signal that you see from the literature, so say in related to cognitive function and creatine supplementation, both acutely and chronically, is associated with improvements in cognitive function. Mm-hmm. And it seems that the benefit increases as you get older. So when they've done meta-analyses of creatine supplementation in randomized controlled trials and cognitive function, there's more of a benefit seen in older individuals. So as far as I know, that there's not like a resistance, and you may actually benefit more as, sort of other systems, or particularly, so say if you're not focusing on methylation and B vitamin status, which probably most older individuals are not, and homocysteine is probably creeping up over time, then perhaps that's where you start to be able to get more benefit from supplements like creatine. So I don't think there's a resistance to that, as far as I know.
So 5 to 10 grams seems to be an appropriate dose, or would you lean high? Would you lean sort of on the upper end of that, on the 10 gram?
I would. I know that people who've run those studies recommend 10. You could be and it's perfectly safe. They've done several year-long studies in older individuals in their 70s taking high doses, like 20 grams a day, with like no side effects. So it's
so interesting. There doesn't seem to be any side effects with creatine. That's one of the it's so interesting. Anyway, sorry to interrupt you. It's one of those compounds where you usually see like an area under like you have too much vitamin D, you can sort of overdo it, with the fat soluble vitamins for sure. But it's interesting that creatine doesn't seem to have, or at least there's been no identified upper limit.
I think part of that is because these dose ranges, say like 5 to 20 grams, they are achievable through regular diet alone. Most people probably won't, but if you happen to be a fan of sardines, which I am, they're a great source of, if you get the whole sardines, they're a great source of calcium, they're a great source of omega-3 fatty acids, and they're also a fabulous source of creatine. There's one tin of sardines has like 4 to 5 grams of creatine in it. So,
wow, I didn't know that. That's awesome.
So if you eat 2 or 3 tins of sardines, or say if you ate, 2 or 3 pounds of salmon or beef, like you can get several grams of creatine just from the diet. So I think one of the reasons why it's so safe is that it's something that you could easily get if you worked on it, right? If you ate a lot of fish or meat, you could actually get that amount from the diet. So I think it's in line with our dietary history, and that's why these doses seem to be perfectly safe.
Choline and omega-3s. You mentioned choline and all of these, talking about the B vitamins as it relates to brain health, cognitive decline, brain atrophy. Do we have a recommended dosage for choline, and do we have a recommended dosage for omega-3s? And maybe with the omega-3s, we might need to parse out DHA as a sort of we might need to talk about EPA and DHA as sort of separate in there in terms of its role in brain health.
The way I think about them is how they have these sort of complementary and combined roles in terms of how they function in the brain. So I mentioned earlier that if you have high omega-3s, but you have poor B vitamin status, you can't get your omega-3s where they want to go. So the way that omega-3s work in the brain is they sit in the membrane of synapses, which is where neurons talk to each other. And they also sit in the membranes of mitochondria, DHA in particular, very important for mitochondrial function. For it to sit in the membrane, rather than just like be floating around as a fat, it's inserted into a phospholipid, which is what these membranes are made up of. So you have the fat itself, and then it's attached to some kind of phosphorylated head group that sits in the membrane. And you don't need to know more biochemistry than that. But essentially, you have two main things. You have the fat itself, which say it's DHA, and then you have a head group, which is made often of something like choline. So you need to have the choline for the DHA to attach to. There are other head groups that are important. So like serine, phosphatidylserine is an important head group. And there are some studies with sort of multi-nutrient supplements that include fairly high doses of serine that have been associated with improved cognitive function. And that may be one of the reasons why as well. Serine is an amino acid. However, in order to attach your DHA to your choline, you need methylation. So that's where B vitamins become important. And so all of these things stack up, and they're all required in order for omega-3s to get into the part of the brain that you want them to be. So I think a good target for most people for long chain omega-3 intake is somewhere like 1 to 3 grams a day, and a fairly even balance of EPA and DHA. Often supplements have a lot more EPA than DHA. So if you're supplementing, just making sure you're getting like at least 1 gram of DHA a day on average. And you can, it doesn't have to be every day. So you can get this from seafood. And say you have a big plate full of salmon one day, what will happen is the omega-3s from that salmon, they'll get stored in your adipose tissue, and then they'll be used as a depot of omega-3s for the brain. So you don't need to eat this continuously. Your body is actually fairly good at regulating stores and access of omega-3s to the brain. But that, on average, somewhere like 2 to 3 grams a day. Choline is another interesting one because several people and like animal studies and some epidemiological studies in humans have suggested that a relative choline deficiency is maybe one of the reasons why we have so much fatty liver in the US nowadays, because you need choline to help export fat from the liver. And there are lots of animal models that no matter how you induce fatty liver, and it can be either with a genetic manipulation or with like a very high sugar diet, if you then give those animals enough choline, they can actually clear their fatty liver. And there are now recommendations for choline, particularly in pregnant women, because choline is incredibly important for both the mother's health as well as for the brain, the developing brain of the fetus and the infant. And I think one of the reasons why this is happening is because of the demonization of eggs, which were our primary source of choline. You can also get it from things like
the liver, yellows, the yolks,
the egg yolk. None of this none of this boxes of egg whites thing. You have to eat the egg yolk. And if you're not eating eggs, or for whatever reason you don't like eggs, then lecithin is a good source of choline that you can get. It can either be made from soy or from sunflower. So some people you can just get it as a powder and you can add a tablespoon to like a smoothie or something. So there are other sources, but the primary source in the diet is eggs, which for various reasons people are generally eating less of. But
it's the whole cholesterol thing. It's the whole cholesterol story that cholesterol is quote unquote bad for you, and lots of cholesterol in an egg yolk, and
lots of really great things in an egg yolk. So I definitely recommend eggs for those who can include them in their diet. And the equivalent of 1 or 2 eggs a day is probably going to be plenty of choline. If you're going to supplement, that's 200 or 300 milligrams a day of acetylcholine or CDP choline. Those are the same thing. They're just ones like the brand name.
That's CITI.
CITI.
Yeah. Acetylcholine. Yeah.
And then, to kind of round that out, there are studies both after traumatic brain injury and in those with cognitive decline that show that supplementing with higher doses of choline improve some aspects of cognitive function. So then we're talking like 500 to 1,000 milligrams a day.
So 200 milligrams to 300 milligrams of acetylcholine, and then 500 megs to a gram of choline in like a head injury type.
Well, if you've had a very recent head injury, I'd probably do 2 grams, 1 to 2 grams. But for cognitive decline, long term, 500 to 1,000 milligrams.
Okay. And then just because we're talking about supplements, I mentioned Thorne, pure encapsulations. There's an omega-3 that I'm trying right now. I think it's pronounced Puori. I might be getting that wrong. Are there brands that you have found particularly useful? Do you use yourself? You may want to just phone a friend or pass on this, and we can if you want.
No, that's fine. I'm happy to talk about supplement sources. I have no relationships with any supplement company currently. But you make a good point, and people have made good points that some cheap supplements, particularly cheap fish oils, I mean, I don't know if they're going to be harmful, but they're probably not going to be beneficial. They can be high in heavy metals, and like all the fats are oxidized, and so it's certainly not providing any benefit. But higher quality supplements are definitely still worth trying, and there are randomized controlled trials where you give people omega-3 supplements, and so say in depression and anxiety, and that people with clinical, say, depression disorder, and you see improvements in symptoms with omega-3s, just like as long as B vitamin status is good, you supplement with omega-3s in a trial and you see improvements in cognitive function. So supplementing has certainly been shown to be able to have benefit. I personally have used, and I know a lot of people recommend, Nordic Naturals. And I know that Momentous has an omega-3 that I believe is pretty good. Other good companies include Thorne, pure encapsulations. They usually are third-party tested. If you're worried about the supplement company, you can ask for a certificate of analysis. So they should have sent off the batch to make sure it's not got a bunch of heavy metals and other stuff in it. And if they can't send you that, then you probably shouldn't buy from them. But all good supplement companies will have that kind of thing. My Icelandic heritage has meant that I grew up with cod liver oil as part of the diet, like a spoonful of oil from the bottle from the fridge, like every morning when I was a kid. So sometimes Icelandic cod liver oil is what I take. And
well,
I don't think
there's a company it's a blue bottle. I can't recall the name, but it comes in like a chocolate flavor too. It's like a
really?
It's a cod liver oil. It's amazing. I give it to my kids in the wintertime. I can't remember. I'll find it for the show notes. But
there's in Iceland, like Lise is the main company, and then Drope is another one where they have this like cold pressed extra virgin cod liver oil capsules. And then I know some people like the Norwegian equivalent, which is Møller's Tran, you can get. But there's nothing magic. I don't think there's anything magic about cod liver oil. It's just that I'm Scandinavian and this is what we're used to. But all those other options are fine as well.
You know, I have to say, I was in Estonia in the summertime. So I'm Portuguese, so part Portuguese. So fish is a big part of our sardines. I mean, I think I was weaned on sardines, but we were in Estonia, and I just had the best. It was like salted, I think was it trout or there was like a big continental breakfast, and I just had all the fish. And, it was like, they they like the eggs and the bacon and the cereal and the yogurt and stuff, and I just went for all the fish. It was incredible because it was right from the sea. It was just fantastic. So shout out to all those northern countries that they do. There's a lot of things that sort of Northern Europe and those Northern European countries do really, really well.
Yeah.
Okay. So we've been talking about muscle mass, lean muscle mass, nutrition. I have, I feel like, in preparing for our conversation, I was like, gosh, this is such a silly question, but I just have to know the answer because I'm so curious. So we've been talking about some of these ways that we can mitigate, or let's say improve brain function, improve cognitive function. One of the things that I don't think I fully understand, which I would love, and this is why I'm so happy that you're here to help round out my understanding as well as my listeners, is why do we have age-related cognitive decline in the first place? I know that's like a silly question, but from an evolutionary perspective, doesn't it seem a bit off that, the elders who have all of this lived experience and teachings that they can pass on to the younger generations is lost? It just doesn't seem like, it seems like it's a bit of an evolutionary mismatch for so many individuals as they're getting older. And this is, again, for my perimenopausal women, I hear this all the time. Like, I have brain fog, I have consonant confusion. I have, like, the word is there, but I can't get it to I can't get the motor signal to my mouth to say it. It's almost like it's a bit of a mild TBI. So can you speak a little bit about why we actually experience this as humans in the first place?
It's a fantastic question, and it's something that I've grappled with a bit recently, and I've written a paper about this, and I'm currently writing more papers with a colleague of mine, Dr. Josh Turknett, who's a neurologist, and we have a podcast about the brain that we talk about this idea.
I'll make sure to link to that too.
But before I get into that, actually, I was reminded as you were talking, particularly as you think about the elders and their role in society, and how you would want their brains to function so they can pass on like the oral history of your society. And I think historically and in indigenous cultures, that is still what happens. And in those cultures, you often see that the things that are associated with cognitive decline in Western cultures aren't risk factors in those cultures. And I think that is part of what makes that's part of what's protective. But there was a very nice study looking at the Bolivian Chimene, which are a hunter-gatherer group, and there's also a related intermediate group, is sort of like halfway between, say, sort of like more hunter-gatherer society and Western society. They're kind of halfway between the two. And so they looked at three groups: the Bolivian Chimene, this sort of intermediate group, and then Westernized society. And what they found was, and this relates to what we were talking about earlier, what they found was that brain volume and energy intake they were looking at. And what they found, that particularly in the sort of traditional hunter-gatherer type society, which is what is part of our communal evolutionary history, say 1,000 or 2,000 years ago, depending on where your recent ancestors came from, they found that the more energy intake that individuals had, the bigger their brain volume. And it actually helped to protect against the loss of brain volume as they got older. So eating enough was really important. But then, when you look across societies, there's this U-shaped or inverse U-shaped curve. So then as energy intake increases even further, it becomes toxic and brain volume decreases again. So maybe one of the reasons why we see this broad decrease in cognitive function in modern societies is generally as we get older, we become energy toxic, right? We're consuming more energy than we require. We know that the average person gains weight or body fat over time, and they become less active. So the in portion of calories goes up and the out portion decreases. So I think part of it is that, and then that relates to broader health. So in general, our health really declines as we get older, and that's not a given. Obviously, we can't prevent aging entirely, but in general, the population, as they get older, they get more sedentary. The quality of their food decreases. They get more stressed, more sleep deprived. And that certainly relates to some of the things that you mentioned. So when you're having issues with memory retrieval, like it's just on the tip of my tongue, like I know it's right there, that's often related to other lifestyle factors like problems with sleep and stress. And these are things that, more broadly don't exist in those kinds of hunter-gatherer societies in the same way. Certainly, they certainly have stresses, but they're not the same kind of chronic stresses. So I think some of it is related to lifestyle and, the deteriorating body composition, more sedentary, deteriorating health over time, which we can certainly combat with all the things that we've been talking about. But to finally get to the point that I was going to make, more broadly, I think the reason why, or a big part of the reason why our cognitive function declines over time is because we use our brains less over time. So when we think about muscle tissue and you want to get stronger, the most important thing is to apply some kind of training to that muscle. And it could be heart muscle if you want to get fitter for a marathon. It could be muscle tissue if you want to get stronger or build muscle tissue. The stimulus is the most important thing. And then after that, the muscle tissue adapts and you get stronger, you get fitter over time. And if you had the perfect sleep and the perfect diet and everything else was great, but you never went to the gym, you're probably not going to get stronger, right? And everything about the process of adaptation to a stimulus in the muscle tissue is essentially replicated in the brain. And most of that had to be looked at in animal studies, but there are also sort of imaging studies and other things that have looked at this. And what it really says is that the amount and how we use our brains, the stimulus that we apply to our brains changes over time. And that seems to be a critical driving force. So in my day job, I run a lab that looks at ways to treat and optimize the development of the newborn brain. And when your brain is developing in the first place, for the first 16 to 20 something years of your life, depending on how many years of education you do, essentially your full-time job is learning, right? Learning to talk, learning to walk, learning social interaction, learning math, learning biochemistry, learning to drive. And during this time, cognitive function is essentially increasing. And it peaks sometime around when you finish formal education, whenever that is. And the longer you spend in education, the higher your sort of peak of cognitive function on average. And then you get a job and you do the same thing again and again and again. And in general, you specialize, right? As you become better at your job and you move up the ladder, you become more and more specialist. And that's important, right? I want a surgeon who has done the same thing a million times, because then, all of the cuts that she makes are the right one at the right time. She knows how to adapt to things when problems arise. But it's no longer this continuous new stimulus to the brain, right? This new skill development, applying a new novel stimulus. All of that stops in most people as we get older. And if you sort of like plot this arbitrary amount of cognitive stimulus, like how much are we learning new skills? How much are we really challenging our brains? as we get older, that decreases, and that decreases in line with broader cognitive function. So I think a big part of it is, how are we using our brains as we get older? And as we stop stimulating them in the same way, it's the same as we no longer go to the gym and lift weights. We're gonna get weaker over time. And the biggest drop in cognitive function is when we retire. So even if you're doing the same thing every day, right, there's still a stimulus from work. The work that you do, the people you interact with, all these other things. When you remove that at retirement, most people, and not everybody, but most people don't replace that with other things that stimulate their brain in the same way. And that's when the greatest sort of rate of increased risk of dementia occurs. So part of it, to go back to your main question, part of this change in cognitive function over time, I think, is going to be some baseline aging process that we can't change, right? We know that body systems slowly deteriorate over time. The scientific community is working on ways to reverse or prevent aging entirely. We can't do that yet. But a bigger part of it, I think, in terms of preventing significant cognitive decline, is related to overall health and lifestyle, sleep, stress, physical activity, that kind of stuff. And then the final piece of that, if not the most important piece, is how are you actually challenging your brain so that you're providing that stimulus just like you would in the gym to make sure that you stay strong as you get older.
So wonderfully said. And if I could boil it down, what I think you're saying is like, use it or lose it, right? Like the function, the function of your brain is going to be proportional to the demand that you put on it, in the same way that your muscle size is going to be, or your muscle strength or whatever, is going to be proportional to the progressive overload or stimulus over time. Okay. So if we have individuals that are listening, they're in midlife, they're looking to sort of, attenuate or at least reduce, slow down that cognitive decline. What are some examples? So I'll give you an example that I'm doing, and you can tell me whether or not this is sufficient or not. So I am a wannabe polyglot. So I want to be able to speak several languages, Arabic. I mean, I can understand all the swear words, but can't read the language yet. But which is, funnily enough, I don't know why, that's always the first thing that you ever learn when you're learning a new language, is all the cuss words. But anyway, So Arabic, I want to be able to speak Portuguese, Spanish, Italian. I already speak English. Someone might argue, maybe not, but, English and French. Is a skill like that where I can, like with French, I like to joke, like, part of being fluent in French is like not pronouncing 40% of the word, unless it's in the feminine form, then you pronounce the whole thing. So I get a lot of times I'll get frustrated with let's say the lack of continuity of syntax or grammar rules or whatever. Is something like learning a language, or maybe there's other better examples, are those things going to be neuroprotective, or are there other things, are there like brain training? I remember, who was I speaking to? They were telling me about an app, I think it was called Dual and Back, where it's
dual and back. Yeah, it's the end back. It's like a working memory test.
Yeah. So are those things that we need to be thinking about as we age? Like, we've all, my ex father-in-law, who I love and still speak to, like whenever I speak to my ex about him, we say like he should never retire because he gets so much pleasure from his work. He's 75. He owns like a construction business, and he gets a lot of satisfaction going in, and like he's not working the same way now in his 70s as he was maybe in his 40s or 50s, but he still has purpose. He still goes in there every single day, interacts with the workers, sees the production line, all the things. What are some things that, is it like, do we never retire? I mean, that's not an option for like, I never want to retire. I love my work, but at some point, I'm going to be 80. I'm going to want to help with hopefully if I have grandkids, I want to spend more time with them and all that stuff. What are some of the activities that we can be thinking about now? I mean, I'm in my 40s, so 40s, 50s, 60s that are going to be cognitive, that are going to be neuroprotective for us.
I think there's no like one skill or that is going to be the most protective. So as with everything, it's the same with exercise, right? Pick one that you're going to enjoy and you want to keep getting better at. But it should also be something that you're bad at. I think that has to be part of, like, I think one of the things I hope people take away is that they regularly engage in improving their skills or their abilities in something that they're bad at. Because adults in general are really bad at being bad at things. Like we hate it when somebody sees us fail or like not get it right. Like, it just makes us all sort of like cringe. It's terrible. Whereas kids, and again, it's part of the learning process, they don't care, right? They don't care if they fall over. They don't care if they pronounce things incorrectly, right? They're constantly pushing the boundaries of what they're currently capable of. And that's the most important thing. We can, look at individual or different types of skills. So languages is a brilliant one. And there are studies that look at people who are either they were brought up bilingual and they seem to get this protection of areas of the brain that are associated with cognitive decline, probably because of that additional stimulus. There are also studies teaching adults languages later in life, and that seems to be associated with improved broad cognitive function. So language is a great one. Music and musical instruments, also a great example. There's one of my favorite studies used this MRI-based machine learning algorithm called Brain Age, which has been used in, I think, dozens, if not hundreds of studies at this point, where they basically originally took hundreds of MRI scans and they just said to the algorithm, this is an MRI scan, this is how old this person is. So then you can give it a new scan and say, how old does this brain look? And they did this in musicians and compared them to sort of age-matched controls. And these individuals were slightly younger. They were in their sort of 30s, 20s to 30s. But what they saw was that professional musicians had younger looking brains than the sort of average person of their age. But amateur musicians had even younger looking brains than professional musicians. And the hypothesis raised by the authors was that for amateurs, it's harder, right? Once you're a professional, you're an expert. It's no longer the same stimulus. Yeah, exactly.
Yeah.
So this is kind of the idea of constantly getting better at something that you're bad at is kind of the key takeaway. And music is a great one. Language is a great one. I think coordination-based movements, and there have been studies with like gymnastics, jump rope, yoga or Pilates, dancing. I mentioned dancing.
Yep.
All of those seem to have these additional benefits.
Any
for the
particular
brain.
type of dance, like waltz, salsa?
I can't remember the type that they did in the studies, but I can't think of any reason why one would be better than another. Whatever you
tempo,
enjoy,
rhythm, what's next, and what's the partner doing, and
and so that's the partner bit. I think is one of all of the activities we mentioned so far. I think there's this potential additional magic because of the social component of it, right? In order to really express the language you've learned, you probably need another person to converse with, right? Just like if you really want to express yourself musically, you might want to do that as part of a band or a group. And dancing, again, fun by yourself, more fun with other people. And especially if it's like a partner-based dance, there's this anticipation and like you're constantly reacting to the other person. And ball sports or badminton or something, it's the same, right? You're constantly having to react to the other person as well as there's another person there. And the social component is probably a big part of it. You also asked about brain training, and some of these things I think can provide some of these benefits. So there's a platform called Brain HQ, which probably has the most evidence to support it. It was developed by Professor Mike Merzenich, who is one of the original people who sort of learned about the process of learning. Like he was one of the original researchers that kind of described how the brain learns in the first place. And they have studies showing that their brain training, which is all online, sort of on a computer base, does have some carryover to like real world examples, like things you'd care about, like being able to remember where your keys are and executive function and decision making and stuff like that. So I think there's a place for brain training, just like there's a place for video games. There are some studies in adults showing that complex 3D video games are associated with improvements in cognitive function. So that's great, but those other things are good as well. And the way that I think about it is that if you're really challenging your brain in a way that's going to drive adaptation, it's kind of similar to going to the gym, right? You're probably going to go for 60 to 90 minutes, or shorter is fine too. Like some people like 30 or 45 minutes, but somewhere in like 30 minutes to 90 minutes, say, and you're going to push to the edge of your current capabilities, right? You're going to say, do a set of deadlifts to failure, and then you're going to rest in between. And that's what we see about these sort of optimal kind of learning periods. They're 30 to 90 minutes. You spend some time kind of pushing the edges of your current capabilities, and then maybe there's some rest periods in between. And you might think about a language class where you show up and everybody kind of like starts to interact. Maybe you learn some new grammar, and then you have a little bit of a break, and then you have like some conversation at the end, right? So it's kind of structured in that same way. So those are the kinds of things that you're doing. Whatever it is, it's difficult. You can probably only do it for 1 to 2 hours maximum, with maybe a few breaks in between, and you're kind of pushing the boundaries of what you're currently capable of, and you slowly get better over time. That's kind of how I think about it.
And the difficulty is that because it's stemming from the frustration of not being able to do it, so you have like more attention and focus on the task to be able to sort of, supersede or get over the hump, let's say. Is this related anyway to the dopaminergic system? I know Andrew Huberman's talked a little bit about this, but would love for you to expand on that.
Yeah, so it certainly seems to be like the frustration and failure of like getting to like the edge of your current capabilities is probably an important trigger for learning, just like focus is really important for learning or making a new memory, right? You need to tell your brain that this is important, and the neurotransmitters involved in that, of course, include dopamine, but also things like noradrenaline and some of these things that are released when we get frustrated or stressed. Some of those create that the environment necessary for neuroplasticity and adaptation. So some element of failure seems to be beneficial. Obviously, it can push you too far, and then your ability to perform dramatically decreases. So there's there's certainly a ceiling effect. But some element there does seem to be beneficial in terms of how we then drive that adaptation. But the other part, in terms of how long can we do it for, if you're using a certain part of the brain, over time you will sort of get a buildup of certain metabolites, right? These are the things that drive sleep, and that will probably eventually lead to some decrease in performance as well. So that's where that like optimal period of real sort of focused learning is probably going to be somewhere in that range.
I think that's wonderful parenting advice as well, just as an aside, because, my kids are in sport and sometimes they're frustrated. Maybe they've lost a game, they're soccer players. So one of the things that we talk about at the dinner table, we do a little gratitude practice, but we also, it's like, where'd you fail today? How did you fail? And what's the lessons and the learnings from that? And I think, I've had, other experts that talk about certain personalities and their propensity to lean into failure versus not. So you mentioned like children, when they're young enough, they don't have that filter.
Yeah.
I think, the age my children are at now, at least they're much more aware of their peer group. They're 11 and 13. So they're very aware of sort of what's going around, who's doing what, who's wearing what, who's saying what. And one of the things that I'm trying to bake into their DNA somewhere, is that this idea of failure is actually one of the best tools for accelerating your skill set. So I have things that I want them doing plyometric stuff at home to increase like the bouncing and the speed and the explosive power that they need to, be able to withstand, some of the sprints and stuff in soccer. But they have to be okay with sucking in the beginning, which is an easy thing to say. Oh, it's okay. You're not going to be great at it. But when you have kids that take after their mom in some respect, who also doesn't like to be wrong, it can be a bit of a hurdle. But I like the way that you explained it in terms of sort of reaching that sort of cognitive capacity, or like brushing up against that edge, let's say, and then backing off, taking a rest, letting the sort of neuroplasticity or whatever, sort of bake up in the background, and then come back to it. Yeah, that's awesome. Okay, so I want to talk a little bit about head injuries. This is something I saw a lot in practice. I think that, maybe it was my physical location of my practice or whatever, but just a lot of lawyers, like I was saying to you. Can you explain what a concussion is? So just, kind of 30,000 foot view from the trees. What is a concussion?
Do you know what? There isn't a formal definition of concussion. There is no agreement as to what a concussion is. So I do some animal and applied sort of clinical work in concussion and traumatic brain injury, both before the impact happens. What can we do to try and increase resilience, and then are there ways to mitigate the effect of the impact? And in that world, I work with a neurosurgeon who's definition is probably about as good as I think we can make it, which is that a concussion is any, and this is impact specific because actually blast type injuries, which are relevant to the military, have a different mechanism of causing damage long term. So an impact, so a traumatic brain injury, it's an impact that causes irreversible changes in the function of at least one neuron in the brain. Now, the problem is that you can't measure the function of one neuron in the brain. So in general, when we think about concussions, you've probably affected large networks or several neurons, because that's when we can actually detect an effect. And that can either be, with functional things like an EEG, which some people do, or, measuring a biomarker, or, you've had frank loss of consciousness or changes in your cognitive function. But essentially, a concussion is anything that results in some kind of change to the function of neurons in the brain.
And you said irreversible.
So that definition is irreversible. And by irreversible, you mean it creates a phenotype or symptoms or some changes. That doesn't mean that you can't recover from it. It doesn't mean that the brain can't repair it, but it means that in that window of time, you have created a detectable change in the function of a neuron. Of course, I think you can have very severe, significant brain injuries that you're never going to recover from fully. But the brain is also very plastic and adaptable and can, initiate parts of repair. So we would hope that one day we'll get to a point where most concussions can be, generally fully recovered from.
And what are some of so again, understand that there's a gradient here, that they can be mild, moderate, and marked. What are some of the symptoms of a concussion?
It really depends on the mechanism and the individual. So when you're talking about terminology, a concussion is thought to be the same as a mild traumatic brain injury, and then they become more severe when you have like loss of consciousness, or maybe if you have like direct injury to the skull or fractures or things like that, and you have significant bleeding in the brain, and those are more severe. But concussions, the skull remains intact, but you have some kind of change to function. The definition of a concussion that includes any change to neurological function, even if it's not detectable, is potentially important, because we know that exposures over time, right? Very small, minor, if we can call them minor, but we can get this accumulation of damage over time, right? So say if you play in the NFL or you play professional soccer, there's certainly now, or rugby, there's certainly now evidence that even if you never had a really bad single concussion where you were knocked out and you had to be carried off the field or anything like that, there still seems to be this accumulation of damage from these sort of much smaller impacts.
Yeah, you've gone up for enough headers in the soccer game.
Enough headers, enough snaps, that those things are probably accumulating over time. So that's where I think that you're causing an effect, even if you can't always detect it. We have to bear that in mind as well. But where you might see symptoms, particularly if you had a more significant concussion early on, they can be changes in balance, right? So issues with the vestibular system, they can be changes in memory. There can be changes in mood. There's often problems with sleep, but it can be issues with, say, working or short-term memory. But often those are very different from person to person. And in general, they settle within a few weeks, but can sometimes go on for much longer than that.
Yeah, we had I had a friend on the podcast, I guess it was a couple months ago, who was talking about his experience. He had quite a traumatic impact. I believe he was riding his bike, and then this woman sort of darted out between, I think it was maybe two parked cars. He didn't see him. He didn't see her. They had this big impact, and he wasn't the same for several years. And one of the things that he talked about, and I don't think he would mind me saying this because he said it on the show, was that he was really irritable. So he would see his kids sort of playing, and before he was like the kind of guy, like the dad that would be down on the floor, rough and tumbling with his kids and, loving them up and all of that. And the only thing he could do was like leave the room because the noise that they were making was so intolerable that it was, and he was a lawyer at the time, and he couldn't, he would have to, and again, there's the lawyer, actually, he was a prosecutor and couldn't, figure out what he was saying in court. He was petrified that he was not going to remember part of his argument, I guess, in court, and had to go on sabbatical, and was just incredibly traumatic for him and his family. And of course, this concussion happened about 10 years ago now, where we are in at the end of 2023. It happened, I think, for him in like 2013. But he talks about this idea of like 2 or 3 years he wasn't the same. And he would wake up every day to see all of the deficits that he didn't even know that he had that were now present. And he, like you and I, very big into exercise and fitness, and all he could do was walk. And there was this, he talked about on the show, this like little group of ladies that would kind of like these 65, 70, year old ladies that would go walking around his block, and they were lapping him, and all he could do, this is the guy that was like deadlifting, like you might be doing, like I might be doing, and all he could do was walk. And he sort of had to come all the way back, like cut out all of the exercise, because those things would give him raging headaches. He couldn't handle the hormetic stressor of the exercise. So all he could do was walk. So maybe that's an example of maybe neurons being activated, maybe more limbic system activation, or maybe the prefrontal cortex was more offline. I don't know exactly where he hit his head, but that inhibitory process of like the PFC sort of like inhibiting sort of these lower brain centers. He talks about like being like more ragey, like kind of more of a ragey, angry person, where, if you talk to him now, he's like a lovely individual.
And this is one of the issues with concussion and TBI research, is that the mechanism of injury for each person is different. The areas of the brain that are affected can be different, and the symptoms can be very different. So then when you're trying to look at interventions, like how do you create a homogeneous group of people so that you can say, well, these people who injured their brain like this, affecting these regions of the brain, we're giving them this intervention. It's really hard to do that, if not impossible. So I think that's one of the things that's kind of slowed down progression of therapies for concussions is how different it can affect different people. But it's worth bearing in mind that early return to physical activity, even if it's just walking, is one of the best interventions for a concussion. So the trials, generally what they do is they figure out what level of activity causes symptoms, and then they do just a little bit less than that, say 2 to 4 times a week. And that seems to accelerate recovery, but making sure you're not making the symptoms any worse, but just enough. I guess it's kind of like skill learning again, right? You're doing just enough that you're not sort of pushing past what you're currently capable of, but making sure that you're doing enough. That's one intervention that certainly seems to be beneficial.
Research on, and I don't know if I haven't seen anything, so I'm asking you, the expert, in terms of women and concussion. And I asked this because it was my very kind of loose clinical observation that if a woman who was still menstruating, so she still had her fertility cycle, if she was injured, she sustained a head injury, let's say in the follicular phase of her cycle, usually, at least in my practice, had a better prognosis, better outcome. And again, there's so much of a heterogeneous group, as you were saying, it's hard to, but my observation was if someone had that sort of full amount of progesterone coming to them in like the next 2 weeks, let's say, I always sort of loosely observed that they did better than an individual woman who, let's say, was hit in her luteal phase, where maybe she wasn't exposed to that sort of 2 weeks or so of progesterone. Is there any data on that, or is that just at this point a clinical observation?
I would be surprised if nobody had tried to explore this, but I have not seen studies that have looked at this, though there may be something out there. Biologically, it is certainly plausible because we know that both estrogen and progesterone are neuroprotective, and there are several trials where they've tried to give progesterone in particular as a neuroprotective agent after different kinds of brain injury. I don't believe any of them have been particularly successful, but certainly in animal models, progesterone is quite neuroprotective, and they've given it, and it was the same in in COVID, there were some trials where they're giving men estrogen because women seem to have a better survival after severe COVID outcomes. They thought it was maybe some hormones were coming into play. And there's a whole bunch of stuff in the brain injury fields and in both basic science and in humans that suggest that there are sex effects. And it's not always that one sex does better than the other. They're just like different depending on the type of injury and all that kind of stuff. So certainly biologically plausible, but I don't know if anybody's really explored that in depth.
That's fair. And so what do we think? So is there any general acute management? So someone has had a concussion. Do we think about, is there basics that we want to be thinking about for acute management, for chronic management?
Yeah. So for the acute management, I generally think about physiology or like managing physiology as much as possible. So when you get an injury, a few things happen, and it's the same across most injuries. But the most important thing one of the most important things is temperature management. I did my PhD in temperature after brain injury, and in general, in animal models, if you cool down the brain after any kind of brain injury, it's very neuroprotective. And what you're doing is you're basically decreasing the deficit between energetic requirements and energetic capacity. So when you injure the brain, your mitochondria become damaged and they're no longer able to produce enough energy to match the requirements of the cell. And then that can make the injury worse, and that can lead to cell death.
You said in animal models.
This is in animal models. So like it gets a lot more nuanced than this, but this is kind of the broad theory.
Yeah.
Like that's what you're doing. And it's very protective. And there is one brain injury for which cooling is the standard of care. It's in term babies who have some kind of event around birth and get a brain injury associated with that. They are cooled down for 3 days to 33.5 degrees average Celsius, 33 to 34.
Human babies.
Yeah. Okay. It's the standard of care.
Okay.
In every other type of brain injury where this has been examined, hypothermia is not neuroprotective. It's been tested in after out-of-hospital cardiac arrest, stroke, and several studies with traumatic brain injury. And in the animal studies, it works. In humans, it does not. There are people out there currently selling cooling caps and cooling devices for things after concussion, and they get mad when I say this, but there is no evidence that these work. But there's a nuance to it as well. The reason, or one of the reasons why cooling is beneficial, is it's not just creating hypothermia, it's preventing fevers. So if you compare cooling to what they call targeted temperature management, which basically means just preventing fever, you keep the temperature in the normal range, they have the same effect. But in the control group, if you let them have fevers like they normally would, hypothermia is beneficial. So the main benefit of cooling is preventing fever. And I told you that whole long complex story just to say that you should try and prevent fevers after a concussion.
It's like an antipyretic,
antipyretic, so like paracetamol and things like that, or Tylenol. Sorry, if we're talking North American.
Yeah.
So making sure that you're preventing fever as much more, and just like preventing the patient from getting too hot. That's important because concussions often happen in heat-stressed environments, right? Say on a sports field or whatever, you're already hot. So just making sure that whoever it is not overheated, and then as the inflammatory response happens in the hours afterwards, trying to keep minimize fevers as much as possible with drugs if needed.
So cold plunges, these are not like cold plunges and these ice caps. This is the ice caps and the grip strength people. They're in the same category, right?
The thing with the ice caps is there's no way.
But how are you cooling the brain with that?
Exactly. So what they do is they measure the temperature of the scalp, and they say, well, the scalp is colder, therefore the brain is colder. That's just not true, because the temperature is coming from core temperature and it's coming up through the arteries into the brain. And if you're cooling from the outside on a cap, you're making no difference there.
Right.
So, there are some potential uses of, say, ice baths or ice vests in this population, and that's as they return to exercise. So I already said that physical activity is one of the best ways. Early physical activity to tolerance is one of the best ways to help recover from an injury. But when you exercise, you heat up. Right, so, there's certainly a case for cooling vests or pre-cooling, some cold water immersion before exercise, we know that helps decrease core temperature and minimizes temperature increases during exercise. I think that can be helpful, particularly if a person is at risk of getting too hot in the week or two after their concussion when they start to exercise. So again, the main thing, preventing fevers or preventing getting too hot in that early recovery period.
And that early recovery period is the first week? Is that
I'd say first couple of weeks. The real danger period is like the first couple of days.
Like 72 hours is where you really want to make sure
exactly.
there's no fever. Right?
Yeah, exactly. And then after that, as you hopefully within 2 or 3 days, you're able to do some light physical activity. That's when you might consider other things just to prevent you. Just make sure you don't get too hot when you start to exercise.
And any research on palm cooling, or just like it's whole body temperature that we're talking about?
Yeah, because it's really so there are some studies on palm cooling and exercise performance, but it's not the same thing. You really want the brain to not get hot, and the cooling the palm isn't going to do too much.
And that's where the cold plunge might work, because you're going to be like, if you're fully immersed, and then the neck.
The cold plunge will decrease your whole body core temperature, and then as you exercise afterwards, you probably have to get out of the cold plunge to exercise. Then it will take longer for your temperature to increase when you exercise. So there's kind of some potential benefit there. The other major thing there are three, but so the second is blood sugar control. And again, in animal studies and in human studies, those with poor blood sugar control, so say you induce diabetes or pre-diabetes-ish in an animal model, or in individuals who have poor blood sugar regulation at the time of a traumatic brain injury, they tend to have worse outcomes. This is important because in general, even in athletes, so say if this is the risk population, but it could be in lawyers if they're getting their heads knocked a bunch, even in those populations who you might think are quite healthy, they can still have poor blood sugar control. So there was a study that looked at Division I and high school football players, and even those in athletic positions, so like quarterbacks, running backs, wide receivers, a third of them, or nearly a third of them, had pre-diabetic level blood sugar levels in healthy young athletes. Of course, you then look at linemen, and the rate of prediabetes was even higher. They've seen similar things in rugby players, in say martial artists, particularly those in the heavyweight categories. At the international level, they have very high rates of fatty liver and metabolic syndrome. So optimizing your blood sugar control and your overall metabolic health before an impact occurs is important. And then also improving or managing blood sugar control afterwards is going to be important as well. There aren't large randomized control studies of this in concussions, but certainly in traumatic brain injuries that require ICU treatment, they know that blood sugar control is very important. And as you have an injury, you have this big inflammatory response that makes blood sugar worse, which is normal. It's part of like normal immune function. But preventing really big swings in blood sugar will probably be helpful. So, as you get carted off the field after your concussion, don't slam the Powerade. I think moving away from refined carbohydrates or large carbohydrate boluses, particularly in those first few days, is going to be helpful as well.
What about ketone bodies? Because even just thinking about the Krebs cycle, when we're using glucose, there's more reactive oxygen species that are sort of spun off as a result of using glucose for ATP production. Would you consider ketone bodies or ketone esters or salts as a possible replacement or sort of band-aid?
Yeah, it's a question that I don't have a good answer to yet. And actually, I'm part of some studies where we're looking at this. The biologic plausibility is great, and there's good animal data. As you sort of have some whole body inflammatory response as you would get from a concussion, or as you become insulin resistant, we know that ketones can bypass some of the issues with blood sugar uptake to the brain that occur in that setting. There are no good studies in humans that say that after a concussion, ketones improve recovery, but there is good biologic plausibility. So I don't, some people, so the trials are happening right now. I don't have a good answer. I could tell you that if I got a concussion, I would do that, but I don't have good evidence to say that it would be beneficial. But I do think that I would decrease carbohydrate intake, particularly refined carbohydrates intake, that's going to cause large swings in blood sugar. So I think ketones are very promising, but the evidence isn't quite there yet.
I hear a lot about, so I'm in Canada, and hyperbaric oxygen therapy here is all but outlawed. But I know that it's available in the States. It's part of actually our, when we renew every year with the governing body, it's like we also have to say we are not providing HBOT to, we have no, so I'm not entirely sure why. I don't, and maybe I just don't know enough about hyperbaric oxygen therapy to understand why our governing bodies have sort of taken that position. But that's also something that I see in the States more often, more commonly certainly than in Canada where I am. Is that a helpful treatment of, maybe not necessarily in the acute stage, but maybe chronically, or maybe in the acute stage? Is that something that we want to be thinking about?
Yeah, it's another one that I probably would put up there with ketones, although maybe some of the research is a little bit a more advanced stage. A lot of the research on, say, HBOT and chronic concussion or traumatic brain injury symptoms is like uncontrolled case series. So like you follow, right, it's a clinic and they have these patients and they're like, hey, we had these patients and we treated them with HBOT for 6 months and they got better. And you don't know whether they would have gotten better anyway, which generally is the trajectory of most injuries. There are some small studies that suggest that HBOT, probably 1.5 to 2 atmospheres for, say, 60-minute sessions and probably over several weeks or months can improve, and these are placebo-controlled, can improve some of the symptoms of concussion. But again, it's very early days. I would say that from talking to some researchers in this area and some of the underlying biology as well as some animal studies would suggest that immediately after a concussion is probably not a good idea, and it may even make the injury worse. But once you get into the sort of subacute period, like after a week or two, then there's maybe some benefit. But again, not a bunch of really high quality studies to support that. So, so say if I got a concussion, it's probably not something that I would do unless I had chronic symptoms for a very long period of time. Then it's something that I might consider, but certainly not in the early phases. Definitely not in the first few days.
Yeah, I don't know how I feel about it. I sort of feel like it's like the grip strength and the cooling cap thing. It's like, I don't really know if this is doing anything. I mean, it potentially could be, as you said, and just the literature is not there. I just sort of have a bit of a hairy eyeball. I'm like, I don't know about that.
I agree.
And then just finally with supplements. So we've talked about supplements already. We talked about choline. We talked about vitamin D status. We talked about omega-3s. We talked about B. Would you just, all of those that we were talking about, would you just increase their dosage if someone had a TBI that they were dealing with? Like you'd still make sure that we were getting all of those. Would the dosage change, if at all?
So one thing, but before we get to that, I would just say that the other major thing to try and improve as much as possible after concussion is sleep, and sleep can become is a big issue. And so obviously all the usual rules apply, but melatonin release can be affected by concussion. So melatonin supplementation may be indicated. If you're having real issues with sleep, then some medications may be beneficial. There's trazodone is the one sort of hypnotic that doesn't affect sleep structure or sleep architecture. So some of the other ones like zolpidem, zopiclone, Ambien would definitely avoid. But if you really need something to help you sleep, then trazodone is an option, but obviously discuss this with your doctor if it's actually needed. So optimizing sleep or as much as possible is going to be really important for recovery. Then
And not reading. This is like my lawyers again. My lawyers always want to go back to reading their briefs. It's like the more you read, the more headaches you're going to have. Yes. Okay.
Well, I guess doing anything to tolerance is fine. So if you're able to read and it doesn't cause headaches, then fine. It's just like physical activity, but don't do it if it's causing symptoms. That's probably another major thing. Like whatever you're doing, if it starts to make your symptoms worse, then you're probably doing a bit too much, and I would back off a bit. Yeah. So supplements after concussions. There's less evidence there's some nice animal evidence and some good biologic plausibility for for creatine before concussions occur, and choline also. There was a study that looked at high school football players, so American football. And over a season, they looked at creatine and choline levels in the brain using an MRI scan, particularly in the motor cortex. And they found that with the more impacts that these players had, the more those tended to decrease creatine and choline in the brain. And one of the ideas of this second impact syndrome, which is that the first concussion doesn't have much of an effect, but then the second concussion that happens in a short period of time is much, much worse than expected. One of the reasons may be depletion of creatine and or choline in the brain because of the first concussion. And then that exacerbates the second one. So creatine after a concussion, it can be beneficial because it can help offset issues with sleep. It can directly support cognitive function. I don't know if it's directly neuroprotective, but it can support cognitive functions. But also, if you're at risk of another concussion, I think that's going to be beneficial. So yeah, I would consider a loading dose of creatine after a concussion. Choline, we already talked about 1 to 2 grams a day. There's some evidence improving neuropsychological outcomes. Omega-3 fatty acids, again, before and after, I would increase the dose of omega-3s. And again, not a ton of really good trials. That a lot of these are being run right now, but I think there's good plausibility and they're very safe. So it's kind of like low risk with high potential benefit. There's a couple of studies, one in more chronic TBI symptoms using an extract of boswellia that seemed to improve cognitive function. And then some other general things I might think about. Magnesium, it can be neuroprotective, but also can help with sleep. Things like that. Those are probably the major ones. And something that I'm a big fan of, again, has some nice studies across the range of animal work as well as human studies in terms of supporting cognitive function, and has some interesting like biochemical effects at like the cellular level, is blueberry anthocyanins. So part of my personal concussion recovery protocol is 2 cups of wild frozen blueberries a day, because the anthocyanins seem to do cool things. And even if they don't do what we think they might do, they're still tasty berries. So probably not a bad thing to try.
At the worst, it's going to be neutral.
Exactly.
Yeah.
Exactly.
And, I wanted to spend a little bit, I'm so happy that you afforded us this extra time to talk about trauma, because head trauma, because the reality is we're all susceptible to it, right? You could get into a car crash, you could be walking down the street, someone, I don't know, my child has gone bike riding and has fallen over, Paul, for example, the example I was giving you before, who was on the show riding his bike, someone sort of popped out, and whacked him. Like you could fall downstairs and hit your head in the morning if the lights are not on. Like we're all susceptible to these things. And so I think that this is a really valuable discussion just as a prophylactic. Like if we just think about, if there's one takeaway, it's like, make sure you're taking some creatine every day, make sure that you're getting enough choline, have some eggs, all of that. Yeah. And some of this, some of the other tentacles of our conversation, I think are going to be incredibly valuable as well. And I think we have to have you back on when some of your research is published next year. So I look forward to hearing more about that as well. This has just been a delight. Thank you. This has just been such a wonderful conversation. Thank you so much for your time. You've been very generous with it, and your expertise, your focus. I think that this is going to be, as I mentioned, so valuable to my audience.
Great. I really appreciate it. Really, really enjoyed this as well. Hopefully some useful takeaways, but no, really appreciated your time and having me on your show as well.
Thank you. And if people want to find you, participate in any of your research, anything like that, where can they find you online? Instagram
is probably where I'm most active, although it's not super active, but when things come up like podcasts, I'll try and share reels and that kind of stuff. So at Dr. Tommy Wood on Instagram. And then I do have a website where some of this stuff goes as well. And I also have like my CV. So if you want to see all the papers that I published, that's drtommywood.com. And my podcast with Josh is the Better Brain Fitness podcast. And it's a question and answer style. So you can submit either recorded or written questions, and we'll try and answer the questions that we think other people would benefit from the answers. So if anything that I've said today has raised some questions, please come over there and we'll try and answer them.
Amazing. I'll make sure all of that is in the show notes. Thank you so much, Doc. This has been just a dream.
Likewise. Thank you so much.